In this lecture, we will explore conditionals in Python. Conditionals are the core control structures that allow our programs to make decisions. Instead of executing code linearly, we can use conditionals to branch off based on specific conditions, making our programs much more dynamic and responsive. First up, the basic if statement. The if statement allows you to check a condition, and if it evaluates to true, the block of code under it gets executed. Let's see this in practice. I open VS Code and create a new file called ifstatement.py. In the file, I define a variable x as 5. Here is my if statement example. If x is greater than 3, then print a message. The program checks if x is greater than 3. If so, it prints the message. Let's verify it. I open the terminal and type python ifstatement.py to run my code. And here is the printed message. You notice a colon after the condition in the if statement. This colon is essential, as it indicates the start of the block of code that should run if the condition evaluates to true. And after the colon, the next line of code is indented. This indentation is crucial because it signifies that the indented code is part of the if block. In Python, indentation is not just for readability, it's mandatory. Here, we use 2 spaces for indentation to keep the code neat and consistent. Sometimes we want to run a different block of code when the condition isn't met. That's where if-else comes into play. It allows us to handle both the true and false outcomes. I'll add an else part to my code. Before I run the code, I'll change the value of x to 2. Now I'll execute the program. This time, since x is not greater than 3, the else block will handle the output. Next, we have the if-elif-else statement. This structure is useful when we have multiple conditions to check, not just a simple true or false. Let's learn this structure with an example. I'll create a new file and name it as elif.py. In this file, I'll assign the value 5 to my variable x. Now I want to check if x is greater than 7. If it is, the program will print a message indicating that. Otherwise, I have 2 other cases to consider. For this, I use the elif statement, which stands for else if. This allows me to check another condition, specifically whether x is greater than 3. If this condition is true, the program will run the block of code under the elif statement. As the print message suggests, x will be between 3 and 7 in this case. I can include as many elif sections as necessary to check additional conditions. Finally, I can add an else block to handle any cases that don't match any of the conditions above. In this example, the else block covers the situation where x is 3 or less, as indicated by the corresponding print statement. I'll run the script by typing python elif.py. As expected, the message from the elif block is printed. You should note that Python doesn't have a switch structure, which you may have seen in other programming languages. Instead, you can achieve similar functionality by using a series of if-elif-else statements. This allows you to handle multiple conditions effectively, just like a switch would in other languages. Sometimes we may need to check conditions within conditions. This is called nesting. It can help in more complex decision-making. Let's give this concept a try by creating a new example called nested.py. In this file, I'll assign the value 8 to my variable x. Next, I'll write an if statement to check if x is greater than 5. If this condition is true, the program will enter the block of code associated with this if. Now, inside this block, I'll add another if statement to check if x is less than 10. This is called a nested conditional because it's placed inside another if block. If both conditions are true, the program will execute the innermost block of code, printing that x is between 5 and 10. After saving the file, I'll run the script by typing python nested.py. As expected, the result will be a printed message indicating that x is between 5 and 10 because both conditions in the nested conditional are satisfied. That's it for conditionals in Python. They enable your program to make decisions based on conditions and control the flow of your programs.